Question 16 says an immersion heater rated as 1000 watt is to be used to heat 20 liter of water from 10 degrees C to 25 degrees C. Assume that 90% of power input is used up in heating water. The time required to heat water is nearly, and the four options are given. Well, the question is essentially based on the concepts of calorimetry. We have to find the time it will take to heat the water from 10 degrees C to 25 degrees C. And the power is 1000 watt, but only 90% of this power is going towards heating the water, and 10% we can assume is being wasted. So effective power being imparted to water is 900 watt. So if the time taken is t second, so we have P effective into T is equal to the mass into specific heat into change in temperature. That means we have P, which is 900 watt, the effective power, considering that 10% is being wasted, only 90% goes to heat the water, into time t in seconds is M. Well, the volume of water is 20 liter and mass we can take as 20 kg, because the density of water we can take as 1 kg per liter. So this is 20. What about specific heat? Well, I'll come to specific heat a little later. Right now delta T is 25 minus 10 or 15 degrees C. So let's put it here as 15. Now let's look at the specific heat of water. Well, specific heat of water, one value we remember very easily is it's 1 calorie per gram per degree Celsius. So it's 1 calorie per gram per degree Celsius. We need to convert this into SI units, and that means we need to convert, well, calorie into joule, gram into kg, and so on. This value will then come out to be equal to, it's 4200 joule per kg per degree C. Not necessarily, this is not completely SI unit because I have used degree C, but it is also 4200 joule per kg per Kelvin, and since it does not really matter because 1 degree Celsius interval is same as 1 Kelvin interval. So we simply need to put this value of S and solve for T. So T is coming out to be then 20 into 4200 into 15 divided by 900, and this is coming out to be in seconds. Let's now simplify further. These two zeros cancel, and let's divide by 3 here, it's 5 here. And well, this 3 also goes off. Here we get 14. So this in the numerator, now we are left with 70 into 20. That means 1400 second. We have to find the time in minutes. So this 1400 second is 1400 divided by 60 minute now. And well, further it is coming out to be 70 by 3 minutes. And among the options, well, 23 minutes is one of the options. This is slightly more than 23 minutes. In fact, it is 1 by 3 minutes, but the closest option is 23 minutes. So we'll take option 1 as the correct one. So option 1 is correct for question 16. Let's now go to the next question. Question 17 says the electric potential in a region is given as V equal to 6xy minus y plus 2zy, where coordinates are in meter and V is in volts. A particle of mass 2 gram and charge 10 microcoulomb is released from point 1, 1, 2 meter. The initial acceleration of the particle is, and the four options are given. Well, what are the concepts involved here? Of course, the concepts of electrostatics are involved. What we can do is, from the expression for potential, we can find the field, and the force on the particle is charge multiplied by electric field. Divide that by mass of the particle and we get acceleration. Now to find the electric field, well, all three components let's work out. So Ex, the x component of electric field, is minus del V by del x, and in this particular case if we take partial derivative of V with respect to x and put a minus sign also, this comes out to be equal to minus 6y for the first term. For the second term and third term it's going to be 0 because there is no x involved there. So it's minus 6y, and if we put the value of y, which is 1 meter, this is coming out to be minus 6 the unit will be volt per meter. So we have Ex as minus 6 volt per meter. Let's now look at Ey, and Ey is minus del V by del Y. The expression for minus del V by del Y, if we take the partial derivative now, is minus 6x from the first term. From the second term it is plus 1, and taking partial derivative of the third term and put a minus sign, of course we get it as minus 2z. Let's now put the values of x and z. X is 1, z is 2. So Ey, we are getting it as minus 6 plus 1 minus 2 into 2, that means minus 4. And well, this is minus 9 plus 1, in fact minus 10 plus 1, so it's minus 9 volt per meter. And similarly, let's find Ez, which is minus del V by del Z, and this is simply minus 2y, and if you put the value of y, which is 1, at this point it is minus 2 volt per meter. So now we have all three components of electric field. The magnitude of the net electric field we know is under root of Ex square plus Ey square plus Ez square, and if we simply put the values, E comes out to be equal to 6 square. Let's say it's 36. So this is 6 square, which is 36, plus 9 square, which is 81, plus 2 square, which is 4, and let's add this up. This comes out to be equal to 121, in fact square root of 121. So this is 11 volt per meter. This is the magnitude of net electric field. The acceleration will be QE divided by m. So let's put the values now. Q is 10 microcoulomb, so it's 10 into 10 to the power minus 6. E we have is 11, and mass of the particle is 2 gram, that means 2 into 10 to the power minus 3 kg. Well, this unit will come out to be meter per second square. And now it's a simple matter of doing the division. After doing the division, you find that acceleration comes out to be equal to 5.5 into 10 to the power minus 2 meter per second square, which is matching with option 4. So option 4 is correct. Let's go to the next question now. Question 18 says, in the arrangement shown, the contact force between the blocks of masses 1 kg and 2 kg is, and this is the situation given. Well, it's a pretty straightforward, pretty easy problem based on Newton's laws of motion. And to find the contact force between blocks of masses 1 kg and 2 kg, what we can do is that first we take all three blocks together as one system. They are all going to have same acceleration, and the only horizontal force on this system is 30 Newton. So acceleration A is 30 divided by total mass, and total mass is 3 plus 2 plus 1 or 6 kg. So acceleration is 30 by 6 or 5 meter per second square. I just repeat, the net external horizontal force is 30 Newton. The system is such that it can only accelerate horizontally, it cannot accelerate vertically, because the weights and normal reactions by the horizontal surface will cancel on the system of three blocks. So acceleration is towards right, and its magnitude is 5 meter per second square. Now to find the contact force between 1 kg and 2 kg, let's consider the free body diagram of 1 kg alone. And on this 1 kg, well, of course its weight is acting downward. It's not really important, but still this is 1 kg into g, and the normal reaction on this. These two forces will cancel. It's accelerating with A only, which we just found. And let's call this force, let's name the blocks as A and B. That means we are calling the 2 kg block as A and 1 kg block as B. So this is the normal reaction applied on B by A, and we can see that NBA will be mass into acceleration again. So NBA, applying Newton's second law, is mass, which is 1 kg into 5, or simply 5 Newton, right? So we have the contact force between 1 and 2, and so we have the contact force between the 1 kg block and the 2 kg block, and this is coming out to be 5 Newton. So option 1 is correct. Let's go to the next question now. Question 19 says, in an AC circuit, V and I are given as V equal to 15 sine 150 t volt and I is equal to 15 sine 150 t plus pi by 3 ampere. The power dissipated in the circuit is. So it's a straightforward question based on AC circuits, and the power consumed in an AC circuit we know is given as P is equal to V RMS into I RMS into cos phi, the power factor, where phi is the phase difference between the current and voltage. In this problem, the value of V RMS will be the peak voltage divided by root 2. That means it is 15 by root 2 volt, because the peak voltage is 15 volt. It's clear from the expression given. What about IRMS? Well, IRMS is also 15 by root 2, but this time this is in ampere. The peak current is 15 ampere, and so IRMS is 15 by root 2 ampere. And what about cos phi? Well, phi is pi by 3. It's very clear that the phase difference between the current and voltage is pi by 3. So cos phi is cos pi by 3, and cos pi by 3 is 1 by 2. So this is the power we have. Well, it is 15 into 15, that is 225 divided by 4 watt, right? So it's 225 divided by 4 watt, and if we simplify this, this comes out to be equal to 56.25 watt. That means for question 19, option 3 is correct. Let's go to question number 20 now. Question 20 says the potential difference between A and B is, and this is a circuit given to us. Let's first find the equivalent resistance of the circuit, find the current. The question is based on Kirchhoff's law, Ohm's law, and so we find the equivalent resistance and the current in the circuit, and then traverse from A to B along any path and find the potential difference. So what about the equivalent resistance? We see that these 2 and these 3 are in series, and so we have 5 ohm here effectively. In the lower branch also the effective resistance is 5 ohm, and these 5 ohm and this 5 ohm, they are connected in parallel, and since they are equal, so this, if I call this point, let's say A and B have been used up, so let's call this C and let's call this D. So the resistance between point C and D of this branch is coming out to be equal to 5 ohm in parallel with 5 ohm, that means 2.5 ohm, and that in series with 0.5. So let's write here, once we have 2.5 ohm and this is in series with 0.5 ohm, so total resistance, the equivalent resistance, R equivalent for the circuit, is 2.5 plus 0.5, or simply 3 ohm, and so we can now easily find the current that is flowing through the cell, and that current I is 30 divided by 3, or 10 ampere. So the current I here is 10 ampere, and since both the resistors, both the upper branch and the lower branch have same value of resistance, which is 5 ohm, so current will divide equally in these two branches, and each branch has 5 ampere flowing. Again, this 5 ampere and 5 ampere join together to make the complete current, the total current 10 ampere. Now to find potential difference between points A and B, let's start traversing from point A and reach B. Well, in this particular case, we can take either path. Let's take this path. So from this is how we are going from A to B. So the potential of A is VA, let's say. Now, since we are going opposite to the direction of current, well, the potential increases by IR. I here is 5 and R is 2. So the change is plus 10 volt. And now there is a drop as we go from C to B, and that drop, because we are moving the direction of current, the drop again is 5 into 3, that means minus 15, and finally we have reached the potential of B. So this is the equation, and this tells us that VA minus VB is simply 5 volt. Pretty simple, isn't it? The correct option is option 2. Let's now go to the next section, which is numerical value type section.